All right.
Good morning, my name is Michael Koss, and I'm here to provide a presentation on the OSI networking model as it is explained in the Network Plus exam. Next slide please. We have 7 OSI layers. They are the physical, data link, network, transport, session, presentation, and application layers. Easy way to remember these, I came up with this yesterday, is use the saying down here, pretty darn nice to sell painted apples. And as it says on there, it can go in either direction. So like, if you're transmitting a data, it would go that way. If you're receiving data, it would go that way. Next slide, please. All right, first up is our physical layer. This is the most often used as the first layer. This is basically represents all your physical components of the network. Your cabling, routers, wireless devices, and even the NIC cards can be considered a physical layer device. Now there are several different standards that are used in the physical layer. Some of these you can actually recognize: USB, 10 base T, that's your Ethernet cables, 10 to 100, 1000 base T, and all those flavors. The devices that provide your 802.11 wireless access. Bluetooth is classified as a physical device if it's the receiver or the transmitter. And again, like I said earlier, copper, UTP, STP, unshielded twisted pair, which is this, shielded twisted pair, fiber optic, and so on. Next slide, please. The second layer is our data link layer. This basically is the key layer between the computer itself and the network. This layer basically takes any packet of data and encloses it in a frame for transmission. The frame can have a MAC address, which is the physical address of its destination. So here's a chunk of data that's going to go from, let's say, this machine to this machine. Inside there is its frame. And that includes the IP address of the transmitting machine, its MAC address of the NIC card, and the sending data for the receiving machine. MAC addressing stands for Media Access Control. This is an address that is specifically burned into each and every NIC card and router that is produced. This is the actual address of your machine. VPNs are virtual private network. Oh, another thing about, I'm sorry, I do have to go back to these. There are no two devices share a MAC address. This is like your DNA or your fingerprints. So if it's like 10 IP addresses, they can be shared. MAC addresses, they cannot be shared. These are hardwired directly into every networking device. VPNs are networks that are virtualized. They're over the internet. For example, if you have a network that's all the way out in Bombay, India, and a network that's here in Detroit, they can communicate with each other over the network. This is done through a process called tunneling. What tunneling does is it creates its own secure link between the two networks. And this allows data to be flown or be sent quickly and easily between the two networks. The data link layer also provides quality of service control. So make sure that all the data gets there in one piece, more or less. If there's a problem with the network, it'll send a request, okay, sending it back again. A couple more of these, it'll start popping up an error saying, okay, we got a major problem here. I'm not getting the data, or it's not sending the data. And another part of the data link layer is the actual wireless transmissions. 802.11a, B, G, and Bluetooth, and stuff like that. So if it's the actual transmission that goes over the air, it's a data link level. Next slide, please. This is the network layer. This is the third layer in the OSI model. That's if you're obviously receiving. If you're transmitting, it's the fifth, I believe. This basically is what contains all your protocols for talking between the two machines. So basically, let's use the UN as an example. There's like hundreds of people at the UN. They all speak different languages. So let's say we got a Japanese representative trying to talk to the Russian representative. Now, if they don't have a standard protocol, they're not going to understand what you're saying. So the protocol, for example, at the UN is the translator. So you got a translator that goes, okay, he's saying hello in Japanese, he's going to translate to say it's hello in Russian. Same thing applies with networks. Protocols are the translations. So let's say you want this machine to talk to this machine over the internet. You use a protocol called IPv4, which is, if you've heard of them, those are your standard IP addresses, 10.1.1.255, for example. And the problem is there's a finite number of these. So some time ago they created a newer version of it called IPv6, which has billions of addresses. And these are easier for people to keep track and individualize, specific machines for. Another version of the IP, which stands for Internet Protocol, is IPsec, which is a secure version of the IP protocol. These aren't broadcast over the network. However, the IPv4 and IPv6 addresses are. Next slide. Transport. This is the fun. This is where a lot of stuff happens. This is the middle layer. Either way, whichever way it's going, it's the fourth layer in the model. This basically breaks down all the data that's being sent into what we call packets. And a good way of putting it is if you're using, okay, let's say you're at, those big pickles you get in the deli. You're obviously not going to be able to down the whole thing in one go. So you use your teeth to break it apart. That's the same thing as the transport layer. It takes a big chunk of data and breaks it into smaller pieces that's easier to transmit. However, on the other side of the equation, it then takes those little chunks at the other side and reassembles them back into the original data. So basically, it's like building and reassembling a puzzle. This also checks for errors in the packet, so which can be caused by glitches in transmission or a flaw in the NIC card, stuff like that. And again, like the data link layer will say, okay, I got a problem, can you send me that packet again? And it'll keep doing this until it has either the whole packet or everything completely dies out, in which case it'll pop up an error. One of the key things in transport layer was something called Apple Talk. Apple Talk for years was Apple's main networking protocol. This lasted so long, it was even included in Mac OS X. However, around when Mac OS 10.6 hit, which people will know as Snow Leopard, Apple finally discarded Apple Talk. But then again, when Mac OS X came about, it was more legacy software at this point anyway, because they started moving over towards more IP stuff like that. TCI IP. Next slide, please. Session layer. This basically is what's in charge of the communications. Basically, a session is when two or more computers are talking to each other. That's a session. What this does is it opens a session, or closes it, or initiates, or ends it, pretty much the same way you talk. Like, for example, Rant wants to talk to, sorry, I forgot your name, Luke. He would open the conversation with, "Hi, how are you?" And Luke would respond, "Well, okay, I'm fine, how about you?" And that starts your communication session. Same thing happens with computers. Some of the main uses for it is in web conferencing. And this sees a lot of use in the session layer because it's doing a lot of work to try to keep the movements of the mouth in line with the audio. If you've ever seen any of the early translated Godzilla movies, you understand what I'm talking about. Where they'll flap their lips and then 2 seconds later you start hearing the text. In a corporate environment, you don't want that. You don't want that. So they use a lot of programs that work at the session layer to sync all that up. And again, we have 2 other versions of dear old Apple Talk, this is pretty much the same thing. Next slide, please. This is our presentation layer. This also receives a lot of work. It's the 6th layer in the OSI protocol, or the 2nd layer if you're sending the data. This is often called the syntax layer. I honestly don't know why they call it that. I just came across the term in my reading. So I just throw it in there. So if you see syntax layer in reference to the OSI model, that's presentation layer. What this does is it delivers the data. This gets all the data that's been gathered. It'll either format it to move it on to the next layer, or if you're sending the data, it'll take the layer and start moving it off down the line. Some of the things it uses, the big one it uses mainly is Telnet. As you can see, this was created in 1969. This is basically the precursor to the internet. It's still in use today. It's mainly used by IBM mainframes, network administration, online games, not World of Warcraft, but like text-based online games like chess, checkers, MUDs, which are multiple user dungeon games, which are like precursors of modern MMOs, amateur radio groups, but it doesn't see as much use today due to people favoring remote login, which is a lot more secure. Because one problem with Telnet was your password and your username, they're broadcast all over the internet. There's no way to secure those. So if someone out there with a packet sniffer goes, hey, password, username, they can get in there and start causing all kinds of chaos. So back to the presentation layer is, what this does is, like I said earlier, it'll reassemble the data that's been gathered so far, and it'll either push it through to the actual application or just move it on down the line. Next slide, please. This is the final layer of the OSI model, or the first layer, depending on which direction it's going. This is your most visible portion, because you may not always see the wires, the NIC cards, and all this stuff. This, however, you will see all the time. These are the programs that deal with the internet or the network itself. These are your web browsers. Yes, please.
Let me just add something in. It's not like a regular program.
Right.
When he means by a program, these are your APIs. Okay? An API is basically a little script that takes you into the world of networking. Okay? So the browser is a program, but built into that browser is an API that allows you into the world of networking. My network neighborhood, network under the new OSs. However you get into the world of seeing other computers, that's the application that he's talking about. Not the Word program, but the portion of the Word program that allows you into the networking world. Okay?
And as he said, web browsers, basically these are like the graphical front ends for most of this stuff. Any program that deals with the internet or with networking, like if you're sharing out a program to someone else, like a Word file or something like that, you're not using the actual Word program for that. You're actually sending it to another program which sends it out to someone else. Some of the more popular ones, or more common ones, are again is Telnet, File Transfer Protocol, BitTorrent. Everyone knows BitTorrent. DNS as your domain name server. Without this, you can't get on the internet. POP, SMTP, IMAP, these are your email programs. Fast Track, what this is another peer-to-peer software. It does have it's not really a program in and of itself, but a protocol. This has a lot of problems though, because a lot of these programs were used illegally for file sharing. One of the biggest ones, of course, was Bronxter. And that's why it's since been shut down, and if you do visit the site nowadays, they do track your IP, they will report you. So. And again, there's a lot more to name here. I mean, I literally found a list online of applications that worked with this layer, and it was long. So, like, there's a lot there to work with. Next slide, please. Okay, this is a review. Again, there are 7 layers in the OSI model: physical, data link, network, transport, session, present.
Any other questions, guys? All right. Thanks, Mr. Koss.
You're welcome, Mr. Jackson. And application, or again, pretty darn nice to sell painted apples. It can be reversed depending on which direction it's going. So obviously, if you're sending out the data, like for example an email, it's obviously going to go through the application layer first and not the physical layer. However, for receiving the data, it'll go physical layer first, then application layer last. Each layer has its own protocols, and as we saw in the demonstrations, some can be shared between layers. One of the examples again is AppleTalk, which shared between 2 layers, and so did Telnet. Any questions?
I have a question. What is the only layer of the OSI model that has sublayers?
That would be, I believe, the data link layer.
And those 2 sublayers are?
LLC, and if I remember correctly, I just came across this question in my testing. I forgot the other layer.
MAC.
Oh.
Right? The media access control, which is your MAC address, and then your logic. Hey, Steven.
We good? Okay. Well, as it says twice.
The link control. Okay.